Okay, so tonight's homework, this is for May 9th, which is going to be Wednesday. And let's take a look at what we have. So what is the difference between the density of the best solid conductor and the density of the soap with the most grams per cubic centimeters? And remember that we're using cubic centimeters. All right, so now let's take a look. What is the best solid conductor? So cork is not a conductor. Dish soap, ice, bar soap, sugar cube, alcohol, granite, penny, water. So the best solid conductor is going to be a penny. And I'm looking at its grams. It says in the density, so we're looking at the density of the best solid, and the density in this column here, coming over here, is 7 and 20 hundredths, or if you take the 0 off, it's 7 and 2 tenths. And then it says, and the density of the soap with the most grams. And so I'm coming over here to the soap, and I circle my density of the soap with the most. Well, if you're looking at here, this is dish soap. So I'm comparing the 91 hundredths to the 1 and 15 hundredths. And the one with the most grams is this one right here, the bar soap. So now I'm going to take the difference, because that's what it asked for. And some of you, if you're still struggling on that one, it's going to help if you're taking the math. If you're taking math, to write your notes down, even next year when you're doing word problems, to write that down. So the difference here would be my subtraction. And so now I'm going to take 7 and 20 hundredths minus 1 and 15 hundredths. Subtract that out. Well, I can't take 5 out of can't take 5 out of 0, so I'm going to regroup. 10 minus 5 is 5. 1 minus 1 is 0. 7 minus, and on my decimals, do the same thing when you're subtracting decimals. Bring down your decimal. 7 minus 6 is 5. Okay, so the most grams is going to be 6 and 5 hundredths. All right, let's take a look at this number 2. What is the difference between, and now I'm having to look for the difference, so I'm going to write the word subtract, between the masses of the heaviest liquid and the lightest solid. So now I have to look at my heaviest liquid. Okay, so cork is a solid, dish soap is a liquid, so I'm going to put an S for solid, L for liquid, ice is a solid, or a soap bar, that's a solid, sugar cube is a solid, alcohol, that's the rubbing alcohol, it's a liquid, granite is a solid, penny is a solid, and water is a liquid. So my heaviest liquid, so let's take a look, dish soap, and I'm looking at mass. My mass is 37 and 2 tenths. Looking at my next liquid, it's 19 and 7 tenths, and my water is only at 1 gram. And so the greatest amount is going to be my dish soap as a liquid, or my mass, 37 and 2 tenths. And then it says the lightest solid. So I'm looking at my solids, and so cork here is 13 and 7 tenths. Ice is 28 and 4 tenths. Sugar cube is 4 and 2 tenths. Looking at my granite, it's 5 and 1 tenth, and I'm looking at my penny, which is 2 and 5 tenths. So it looks like my penny wins again. I'm going to circle it again and circle here. And so now I have 2 and 5 tenths. I'm needing to take that difference away. Can't take 5 out of 2, so I need to regroup. And this becomes a 6. Take my 1 over to my tenths. So I have 12 minus 5. And it's 7, because 7 plus 3 is 10, plus 2 is 12. Bring down my decimal. 6 minus 2 is 4. 3 minus 0 is 3. So my answer is 34 and 7 tenths, and the answer is C. Okay, look over here. which substances would float in water? Okay? Which substances would float in water? Do all liquids float in water? I put a check mark. It was supposed to be no. That's a false statement because oil, rubbing alcohol, we've noticed that some of it sinks, some of it floats. So those were all different levels. So rubbing alcohol. All solids? No, not all solids float. That is false because we're looking at what floats. Okay. Does a bar soap, sugar cube, granite, and penny float? Well, if you weren't sure about any of them, let's look at the density grams over here and take a look. So let's see. And now let's look at cork. We know cork because it has 0.2400 dish soap. So which will float? Dish soap. So that is 9100. Ice is 9300 in their dense. And then we have alcohol is, and we're looking over here, 7900. Okay? So if we needed to put it over here, our bar soap for density is 1 and 1500. The sugar cube is 1 and 5900. The granite is 2 and 6500. And look at where I'm getting my data from. In the column it's mentioned density, and I'm looking at what the density is. And a penny is 7 and 20 hundredths. So these guys would probably sink way to the bottom, maybe float in the middle, or close to the bottom. But they're not going to be floating. They'll sink or get close to the bottom, but they're not going to float. Whereas this one is less than a gram. If I look at my water, it says my density of water is 1. And remember yesterday we were talking about buoyancy. So these here will float. These here will sink because the density is more than water. Okay? Alright, so if you need to pause it, take a look, replay it, please feel free to do so. Alright, so using this evidence in the diagram, answer true or false for the following. Alright, so on this balance beam, let's just call it balance beam, you have 1 gram, 2 grams, 3 grams. Well, over here you have X, Y, and Z. So this one here, if it's down here, that means that there's more grams here and less grams there. So let's look at this first one. We have to place true or false. The smaller cans, these are the smaller cans. So I'm going to put smaller cans so I don't get confused. Have a total mass of 3 grams. Could these be 3 grams? No, because then it would be equal. So that's a false statement. If these cans were 3 grams and this is 3 grams, then that would have been equivalent, and that's not. So I'm going to put false over here. Can X, I'm looking at this can right here, is more dense than one of the gray cans. And actually this here, if you want to take your pencil and kind of shade that in, these are actually gray cans. I don't know why it didn't come up here. But we'll shade that in right now. Okay? So can X is more dense than one of the gray cans? If this was more dense than one of these, then this would have been more than 3 grams. So that's a false statement. Okay. So if we took, I think I said that wrong. Can X Can X is more dense than one of the gray cans. So this one can't be more dense because look at the size of it. So it's going to have less, um, it can't be more dense than one of these here. Because we're not talking about mass, we're talking about density. The combined mass of cans X, Y, and Z. Combined mass. Because remember, this is grams. And we're measuring mass. And here we're talking about more dense. This we're not putting, what is it? We're not doing anything with density right there. Okay, so here, combined mass of cans X, Y, and Z are greater than 3 grams. True statement? Yes, absolutely. This has to be greater than 3 grams. So whatever this is here has to be greater. So it can be 3.1, 3.2, 5, 7, 8, 9, whatever it is. The gray cans would float in water. So we're looking at the gray cans. All right, if we know that water, its density is 1 gram, right, or cubic centimeters, these are 1, 2, 3 total. Would they be able to float? The answer is no. They're not going to float, they're going to sink. So it's false. If can X and can Y are both 1.1 and 2,500 kilograms, can Z be 5/10 milligrams? Okay, so I'm going to take my both cans and 1 and 2,500 plus 1 and 2,500. Bring down my decimal here, add those up. 5 plus 5 is 10. Carry my 1, 2, 4, 5. 1, 2. So that's 2 and 5/10 or 50 hundredths. I'm going to add another 5/10 or 50 hundredths. 5 plus 5 is 10. Carry my 1. That's 2, 3. So it can't be because, again, we're looking at this side is 3. And this side cannot be 3 grams because otherwise it would be equal. And I'm sorry, and I'm putting grams, it's kilograms. And this would be 3 kilograms. So no, it can't be because that would be equivalent. So that's not a true statement, and that statement is false. So here it's pretty much just thinking about it. Remember, you're not measuring any density, and you would have to imagine if you put this less based on your information, it would probably sink because it would be more dense. All right, let's turn to the next page. All right, define and draw examples of each type of energy. Okay, so energy type, energy, mechanical energy. So mechanical, I'm going to draw my little lines here, and I'm going to draw a baseball. Because in order for this baseball to move, I have to throw it. All right, in order to ride a bicycle. Now, my drawing is pretty poor. So I'm going to draw one tire here, and then I'm going to draw a little bike here. A little handlebars here. And then this here is a little seat. In order for this to work, I need to have my pedals here, and then my pedals here. And hi. Okay,